Hi, and welcome back to part 2 of our video on manipulating the data for our desiccant lab. I've turned off our camera because I'm running out of space, but hopefully you can hear me just fine. So we worked really hard to get this number, which we think is probably very important in helping us to determine the quality of the desiccant, but that might not be the only thing that we care about. So in this film, let's talk about the other pieces. So I'm going to go out to Safari, and I'm going to go to our web page, Chemistry Honors. And this is the Designing the Best Desiccant. And you'll notice that over here in this side column it says Designing the Best Desiccant, and I'll move out that way. So I had added some things here recently, including the Hydrates Lab group analysis. So I'm going to open that up. For me, that's just a download. So I'm going to come over here, click that. Let's make this a size that you might be able to see, and something like that. Okay, so this is what we needed to do within our group. In fact, I should edit that because it's really two of the hydrates. We had to do all the calculations. We had to incorporate the right number of significant digits, something I talked about in the last film and I will again in this one. And I showed an example of building a results table. But down here, we might also want to do some research on cost and toxicity and availability and all that good sort of stuff. And that's what I want to focus on right now. So let's get out of that. And let's go back to our page here. So in order to do that, I'm going to navigate here to the Flynn Scientific website. Okay, this is Larry Flynn. You think I have a cool lab coat? He's got the best. And over here, I can type in my compound, which was cobalt chloride. So this should take me out to Flynn Scientific's cobalt chloride inventory and how I might purchase it. Now I don't want anything that says solution because that means it's in a liquid form. That wouldn't work very well for me. I don't want any test papers. Oh, here we go. This might work, 100 grams of it. But maybe I can get it in a better form, maybe a little, well, that's smaller. Oh, here we go. This is a bigger batch, 500 grams. And I know that typically the more I buy, of course it's more expensive, but it's usually less expensive per gram. So let's click on that. Oh, and here it goes. It says that for my 500 grams, they will charge me $40.25. So before we go any further, I want to write down this value. Okay, so I'm going to go back to our Mathematica page, and I'm just going to, as a text insert, I'm going to write, it's going to cost me $40.25 for 500 grams of what we're going to call the wet compound, right? Because it has the water still in it. Okay, let's see what else we can find if I go back to that web page. Oh, look at that. This is indeed the water-filled compound, and it tells me that I should be concerned about some hazards. So I'm just going to highlight that, and let's put that into our page as well, because that sounds important to know. It says possible carcinogen, which means that it is a cancer-causing agent. Even if you inhale just the dust, can cause damage to the blood. Really not a good thing to eat, it says. Oh, and then this says LD50. This says what is the lethal dose for 50% of the population, and that's per kilogram of body mass. So it says about 3/4 of a gram per kilogram is enough to kill somebody. So maybe this is something we don't want to use. But that being said, let's go and play with this number a little bit. Okay. So I'm going to put this down. I know that it's going to cost me, I think it said, $40.25 for 500 grams, right? So I'm tempted to say that that's my cost. It's going to cost me about 8 cents per gram of compound. But you'll remember that the 500 grams are full of water and not a desiccant. So the best thing for me to do, I think, is to say, let's go up here and say, but you know what? That's how much dry compound I get. For this amount of wet compound. Right? I'm going to take the dry off just so Mathematica knows what to do with it. And the answer that I'm going to get now, I think, is saying that, well, really, I'm paying a considerable amount of money for just the water. So let me back up a little bit. Okay, let's take this off. And let's find out how much it's really going to cost me. So my 500 grams, let's call that the wet, can be multiplied by this ratio of this amount of dry, we'll call it the dry compound, for every, whoops. So I'm using my actual data here. The grams wet and the grams wet should cancel. And the answer I'm going to get is, okay, so for the $500 that I've bought, I'm really only going to get about 272.79 grams worth of dry. Okay, so let's go forward with that. If I have 272.79 grams of the dry compound, and it's going to cost me some money, right? It's going to cost me $40.25. So let's do it this way. Let's type in $40.25, and I'll just write that as dollars. And this I'm going to copy and put right there. Because I really want to know what's it going to cost me for every gram of my dry material. Oh, this is a very different answer. It says because there's so little dry compound in those 500 grams, it's really going to cost me almost 15 cents for every gram. Now let's figure out how many significant digits we should have. This has only 3 significant digits, which means this answer can only have 3 significant digits, which means this really has only 3 significant digits there. So this can only have 3 significant digits, and I will have to trim it at the 7. So my decision to make is that 549 is more than halfway towards 8. And so up here, let's just insert in my table matrix a new row. And let's call that cost per gram of dry compound. And so for this one, scrolling back down here, it looks like it's going to be 0.148 grams. 0.148, and that's going to be dollars, right? And that's per gram. Now this number is pretty important because we don't want to spend a lot of money on our desiccant, and yet we want the desiccant to accomplish a lot, and we want it to collect a lot of water. Okay. So that's one way of comparing things, would be based on cost. And that was a way of figuring out how much I'm really getting for what I've purchased. So as I did before, I'm going to clear some of these just so that we can move our way back up there and kind of remember what's going on. Okay, so the last question that we might ask is, so let's imagine that we want to capture 10 grams of water. Okay, so let's imagine that we're trying to build a desiccant that can capture 10 grams of water. How many grams of compound are required to do that, and how much would it cost? That might be a way of comparing things. So what could I do? So let's see. I know that for every, let's see what I have up here. I have mass of the wet, mass of dry, difference. That's how many grams of water there are, right? So let's see. I know that I will get, let's put a ratio in here, 1.179 grams of dry at the same time that I get 0.198 grams of the wet, of water, right? So if I stopped right there, it would say, so how many grams of dry compound do I need? So for this compound, to pick up 10 grams of water, I would have to have about 12 grams worth of cobalt chloride that I have dried. So that might be interesting, so let's put that in there too. Let's add that, let's add that row. And let's call it amount of dried compound to absorb 10 grams water. And so for us, the answer here would be 12.0 grams. Okay. Now let's go one more step further. I think we learned just a minute ago how much that's going to cost me, potentially, right? Because for 10 grams of water, right now my grams of water have canceled, right? And this number up here was per grams of dry material. So if I just decide to insert another multiplication, control slash, I know that for every 1 gram, oops, I did that backwards. For every 1 gram of the dry compound, we had written down that it's going to cost us 0. Actually, it doesn't like the dollar sign very much, right? So $0.148. And so if we stop right there, now my number says, okay, what's it going to cost me to pick up 10 grams of water? So I'm going to insert one more cell here. Where am I? Oh, insert, table matrix, add a row, and cost to absorb 10 grams water. And I have an estimate here that says it's going to cost me 1.7, what are you going to do here? I'm going to round up, right? $78. So that's a way of looking at this a bit more comprehensively. I know the percentage of water. The higher that number, the better we think the desiccant probably is. The lower this number, probably the better, right? The less I have to pay per gram of dry compound, a good thing, right? This is now saying, okay, well, pick a number, let's say like 10 grams. How many grams would I have to put in my desiccant packet to get those 10 grams? This number might be very important because the lower the number, the better, right? Because we don't want it to be heavy. We don't want to pay the shipping weight. And then we always worry about money. To get those 10 grams of water as an insurance policy on our compound or on our package of iPods, that should cost me $1.78 in terms of material costs. So that might be a good way of comparing those numbers in conjunction with this hazard information or the availability. That will go a long way to helping us figure out what's the best compound. So I hope that video will help you and that you can do a similar type of analysis on the compounds that you tested in class. Great, thanks.